So we learned that VXLAN, a virtual extendable local area network, uses UDP, and it works on top of UDP. It's MAC in UDP. But for UDP to work, there is a proper IP routing is necessary. All these things we learned. We learned the advantages, the benefits of VXLAN. And today we are going to see the configuration side of VXLAN. See, VXLAN provides you a layer 2 overlay. It provides you a layer 2 overlay. How do we configure this is what we are going to focus. If you see here, we have four scenarios. Four scenarios of layer 2 VXLAN. One is back-to-back using multicasting. The second one is back-to-back using ingress replication. See, for these two, there is no need for spine device. So this is widely seen in service provider environment. You don't need a spine environment. Internet will act as a spine environment. So you got a back-to-back multicast replication method, back-to-back ingress replication method. Two things you need to remember, because this is what the word that interviewer is going to use. Ingress replication, back-to-back multicast replication. Both needs BGP, but multicast replication uses multicasting in order to answer that BUM. What is BUM? B stands for broadcast. U stands for unknown unicast. M stands for multicast. If there is a broadcast packet coming, who attends to that multicast? If an unknown unicast packet comes, what does that mean? If the destination of the packet is unknown to the switch, we call it as unknown unicast. Unknown unicast. It's a unicast, but because you do not know the destination, you need to flood now. Though it is a unicast, you need to broadcast now. You need to flood it now. So who takes care of that unknown unicast? And who takes care of the broadcast? So if there is a broadcast, if there is an unknown unicast, if there is a multicast, who takes care of such traffic? Multicasting. If that is your solution, then this is what it means: multicast replication. To answer those BUM traffic, if you do not want to use multicasting, you can use BGP to. If you do not want to use multicasting and you want the answers to the BUM traffic, I do not want to use multicasting, but still I want something to take care of my BUM traffic, broadcast, unknown unicast, and multicast. Then I have to use BGP. We call this ingress replication. When you use BGP as a solution instead of multicast, if you want another option to take care of the BUM traffic, BGP is the answer. And when you use BGP as a solution for VXLAN, you call it as ingress replication. Ingress replication is the one where BGP is used as the solution for BUM traffics. Now, this is back-to-back multicast replication we are going to see, after which we will see back-to-back ingress replication, which is going to use BGP itself to provide the answers for BUM. So both does replication, one using BGP, it replicates the MAC address and the VTAP address of the connected devices. And the first one uses the multicast to replicate that that connected device MAC address and the VTAP address information. Now the third method is you use a spine, maybe kind of data center environment. Spines will be there in data center. In service provider, it is rare to see that because it is not possible to have a spine because internet itself acts as a spine. In data center environment, you may have many leaf and then some spine. In such scenario, how are you going to do multicast replication and how are you going to use in-grease replication? These are the things, 4 things. If you finish, you are the master of BGP, VXLAN, EVPN. 4 things. I have already shared you the link. I'm going to walk you through this commands to explain how the working happens, the working principle. Now, before that, I would like to show you one more thing with the help of this picture. If you see this picture here, there is a rendezvous point. Have you both finished multicasting? No. Okay. See, when you do multicasting, I think that should be the next topic after we finish this. Please remind me, multicasting should be our next topic. Now, when you use multicasting, in multicasting there are 2 modes, dense mode and sparse mode. Wait, sparse. Sparse. My pen is not writing properly. 1 minute. Sparse mode, not SCC. Sparse, S-P-A-R-S-E only, correct. Sparse mode. Dense mode and sparse mode. Dense. Dense means thick. Dense mode and sparse mode. What is the difference? Dense mode is, as the word says, dense, meaning it is flooded to every router. To all it is given. To every router, the multicast packet will be flooded. To all the devices in the topology, the multicast traffic will be spreaded, even if there is no one to receive. The multicast traffic will go and get dropped. We call this flooding and pruning. Flooding and pruning. Dense mode is flooding and pruning. Sparse mode will not flood to everyone, only to those who have got some receivers of the multicast traffic. Now, Nexus devices, they do not support dense mode, which is very easy to configure, but it is not supported. So, we obviously end up in using sparse mode. Sparse mode is using a mediator, a reference point called rendezvous point. Ko knows what is meant by rendezvous. What is rendezvous, Ko? Rendezvous means it's a meeting place. Meeting place. It's a French word. Rendezvous means gathering place, meeting place. So we have a rendezvous point, a router as a rendezvous point, from where the source will know about the group members of the multicasting, and group members of multicasting will know the source by reporting themselves to rendezvous point, because everyone comes to the rendezvous point. So with that rendezvous point, the source will know the members of the multicast group, and the multicast group members will know the source. That's why we need the gathering point, rendezvous point. So we configure one of the router as a rendezvous point because our first lab is multicast replication. We use multicasting as a solution for replicating the MAC address and the VTAP addresses of the connected devices. The reason is you use multicasting to answer those bump traffic which meets the MAC address of all the connected devices and the connected switch VTAP address. We need RP, rendezvous point, which is not necessary, which is not needed in increased replication. In increased replication, we will not configure rendezvous point because you don't need a multicast to do the replication. You use BGP, which will do unicast. BGP will learn the neighbors. With a neighbor, it does unicast. That is how it replicates the MAC address. Yes, BGP can carry the MAC address and the VTAP address of all the connected devices. So we use BGP to replicate the informations of one switch to the remote switch. That is how the learning happens. That's how the devices learn about the connected remote devices. If you use multicasting, then you need rendezvous configuration. You need to configure sparse mode. You need to configure rendezvous. You need to configure sparse mode. You need to configure PIM. What is PIM? Protocol independent multicasting. Without enabling PIM, you cannot have multicasting. You need to enable PIM on all the routers in the path. Only then you can have this. You know, all these things are involved when you talk about multicast application. I repeat. Along with the VXLAN configuration, PIM configuration, protocol independent multicasting, rendezvous point configuration, and sparse mode configuration are involved. Only then you have multicast replication method for layer 2 VNI back to back. Whereas for increased replication, we will make use of the BGP which is already running to provide you the VNI circuit, the VXLAN, to replicate the bump traffic. Instead of mapping the bump traffic to multicasting, we will be mapping it to increased replication, nothing but BGP. I repeat, in the first method of multicast replication, you will map the bump traffic and you will map, let me take you to the configuration, show you what I am talking about. Here, you map all the bump traffic to a multicast. So any bump traffic that is entering into this VNI, into this VXLAN tunnel, need to be delivered to this multicast. Whereas in BGP increased replication, if you see, let me take you there. This is increased replication configuration. If you see here, you take those bump traffic and give it to increased replication, which is nothing but BGP itself. See, both uses BGP, I repeat. If you see this line, it is similar in both multicast replication as well as increased replication. This line is same. Both needs BGP to form VXLAN tunnel. But inside the tunnel, who carries the bump traffic is determined by this second line, in the next line. In here, because I use the increased replication keyword, it will use BGP itself to do it. Whereas in the above one, in multicast replication, Even though the protocol is BGP, see host reachability protocol means VXLAN tunnel comes up using BGP, the bum traffics are handed over to a multicast address. See, 224 to 239 is multicast. 224 to 239 is multicast. Here I'm using 225, which is also a multicast. You see, I have shown you the very important configuration difference that makes two separate methods. That is where these two vary. All the rest are similar configuration. That's the only place it varies. This first two. So shall we get into this two now and go through the steps? Are you ready? Do you have any question or do you get some understanding now? Let us now get into the configuration part. You see, the first method is multicast replication. What does that mean? It means that the MAC address of the connector device. So this is the MAC address of the connector device. Here it is connected. The MAC address of this connector device is given to the remote VXLAN tunnel peer, isn't it? This is a VXLAN tunnel peer. Do you agree? The tunnel is formed between these two. Now, someone should advertise the MAC address of the connector device and the address of this switch itself to this guy, so that that switch will know who is connected where. Likewise, the MAC address of this device and the VTAP address of this switch needs to be advertised to this switch. Who does this? It can be done through multicasting. It can also be done through unicast via BGP. Now, why it is so important to replicate it? If you don't replicate, then when an unknown unicast comes, the switch will not know where is the destination. Because the destination is given now through multicasting or through BGP, you can answer the unknown unicast. This guy says, hey, I'm sending you the packet with this MAC address. But before this guy send it, the switch already knows. So that there won't be any unknown, someone should beforehand advertise this thing so that those things will be handled. In case if this switch also do not know, a packet is coming with some MAC address and the switch do not know. And yeah, you see, most of the time when a device comes up, a tiny packet will come to the switch. From that tiny packet, it's kind of keep alive. From the tiny packet, the switch will know that I have this such and such MAC address connected on port G1/0/10. Likewise, this MAC address will be learned here, 6CC2 connected on G1/0/10. Now, when the new MAC address learned like this, immediately the multicast or increased replication BGP will advertise it, replicate it, saying, I am 172.16.255.1 speaking. It will say, it's me giving you, I got this MAC address. So when this switch, second switch learns, it learns like this, 6CC1 is connected to 172.16.255 dot 1. It knows which switch is having this particular host. Likewise, when switch 2 advertises, switch 1 learns that there is 6CC2 connected with whom? 172 dot, that's called VTAP address. That's the ID of that tunnel endpoint, virtual tunnel endpoint, VTP, VTAP. 172.16.255 dot no, that's wrong. It should be unique. It's a mistake. It is 2. Okay, it is 2. Let me show you on the page. That in the picture it's a mistake. On the picture it's a mistake. But if you see the configuration of that loopback interface IP address, you see here it is 1 here and 2 here. Now, wait, I have not finished. So the attached device informations are shared. But what if this PC send a packet with the destination MAC address which is nowhere learnt? What will happen when this unknown unicast, is it a broadcast? No. Is it a multicast? No. It's a unicast. I want to send this packet to A. But where is A? Switch does not know. That's called in BUM, that is that U, unknown unicast. When the unknown unicast packet comes, then what should switch do? If it is a multicast, it will send it to the other multicast peer, which is the other end of the tunnel. If you have more than one, it will go to all. Who carries it? Multicast carries it. If you have BGP, then BGP will do unicasting, replicating, forwarding the packet to every IBGP members. If you have more members, it will send to all IBGP members as a unicast. When you use multicasting, it goes as multicast. When you use BGP, increased replication, it goes as a unicast. It's the same answer if you send a broadcast. In case if this is sending a layer 2 broadcast, assume a layer 2 ARP request or DHCP, discover. What should it do? It needs to forward it to all because it's a layer 2 broadcast. You can forward it using multicasting or you can forward it using BGP. Same story, multicasting. If you want to do multicasting, if you want to send to every member of the group, you can use BGP, which will do unicast for this multicasting. Means for every member of the group, it will send a unicast traffic. If you are using multicasting, it is multicasting, obviously. So, which method you want? Do you want multicasting to carry the BUM traffic, or you want unicast, which is increased replication, which is via BGP? You have to decide. Multicasting will always flood when a BUM traffic comes. Not only that, when a new MAC address comes, it will flood to everyone. Always. Flooding to everyone is not every leaf. Flooding to everyone who belong to that VXLAN. Yes, question please.
Yes, sir. When we use multicast, it will be more faster than BGP, right?
But flooding is not okay all the time. Oh, right. So BGP will use the communities to identify the target and to which the target will be delivered. Again, you are not going to configure any VRF, you are not going to configure route destination, you are not going to configure any route targets. Those things are automatically created and configured when you put some commands. I'll show you those things. Question, anything from any question from Co?
No, I understand.
Okay.
I'm curious. I'm curious to see that comment.
Okay. You're very curious or a little curious?
Yeah,
You're very curious. All
because
right.
if it takes motivation,
Oh, okay. That you want to know. Okay, fine. Let's do. You see this? First of all, this should be there and it is already there. Every device by default, this command will be there. You are not going to type this command. Okay, see, this is show running configuration of the leaf. So you will see a lot of default configuration. This is needed because you are going to use multicasting for replication. I told you there are two ways in replication: increased replication and multicasting. When you use multicasting as a solution, you must have this command, which is not needed for the next method. And this one is L2VPN EVPN, replication type static, router ID loopback 1. This will also be same for both. Now there will be slight difference in this one. Wait, let me check and tell you. There will be slight variation in the command. I want to go to ingress replication. This is ingress replication. Sorry, it's the same thing. For ingress replication also, it's the same thing. Next is here we say in multicast replication back to back, we say L2 EVPN instant. This is just a number, but I'm using 101 here because the host which I'm connecting here belong to VLAN 101. This is an access port, member of VLAN 101. Just to to make sure I don't mess with the numbers, I use the same number for EVPN also. You no need to use the VLAN number here. But for consistency, I'm using that VLAN number which the host is using. All that you need is one unique ID for this VPN, because you may have many instances of EVPN. So I'm giving 101, it can be 1 also. And VLAN based, meaning I'm going to take the traffic from VLAN and give it to VXLAN. That is what here I mean, encapsulate using VXLAN. And usually this will be default on Nexus devices. In other devices, if you are doing, make sure you increase the MTU. This is the way. Jumbo frames, yeah, of course. Now, this is the way to configure VLAN in Nexus device. In normal iOS device, we will say VLAN 101. There you say VLAN configuration 101. And then we say this VLAN has got a member of EVPN instant called 101. This one, I'm calling this one. And I'm giving a VXLAN ID, VXLAN segment ID, which is called VNI ID. So all the traffics that is in VLAN 101 will be placed inside 10101 using the VXLAN encapsulation. Whereas in EVPN using ingress replication, after this there will be a mention about replication, ingress replication. You see, replication type ingress. This is in ingress replication. In multicast replication, you no need that command because you are going to use multicasting. See, parallelly, I'm showing you both the configuration. It should not confuse you. It should make you more clear. It may sound like a little bit confusing, but if you spend some time, it will be more clear. For multicasting, why should I say this word replication type in English? No need. It's by default. All other things so far is same, like for both same. Only one line additional you need to add. After this, replication type is English for the second method. Next. These things are same for both. It's the same thing. All these things are same. And loopback interface, IP address, should run OSPF, all these things are same. All right, there is no difference. The only difference you're going to see now is the sparse mode. They need to run multicasting. This is the command to enable sparse mode, which is not needed in increase replication. See, there is no command called sparse mode. There is no multicasting. It's just only OSPF. Whereas here, along with OSPF, you need to also run the sparse mode PIM. You need to enable because you need multicasting. And then I told you the host is connected to a VLAN. So the host connecting port, if you see the picture, is G1/0/10. Here, that interface should be configured as switch port mode access, switch port access VLAN 101, and port first. You know about port first. You have to enable port first so that you don't wait for BPDU responses when there is a topology change. Next. And on this WAN interface, where the tunnel need to be established, you must enable the sparse mode, enable the OSPF. This is an optional one, point-to-point network type. If you don't say this point-to-point, then there will be a DR-BDR election. To avoid that, you may say point-to-point, because you got only two routers. And then this is the main story. The virtual interface for VXLAN is called as NVE, Network Virtualization Edge. And then the source interface is going to be loopback interface, and the reachability protocol, I told you for both reachability protocol is BGP. But the replication protocol here is multicasting, whereas in increased replication, it is going to be BGP itself. So this line is not needed if you are running BGP, right? This line. What? Come again? OSPF is to provide reachability. See, if you want to have IBGP, EVPN, if you want to do BGP between loopback to loopback, you need a routing protocol, right? You need reachability, right, between these two routers? What happened to you? You're not responding. You asked me a question, I'm answering, you're not answering. You need to ping between, in order to form BGP, see, there is a BGP neighbor statement coming here. If you want to reach this guy, you need reachability, right? For that, you need OSPF. Hello. Yeah, I hear you, but did you understand why we need OSPF? If I want to have neighbor between this and this address, which I'm using to form BGP neighbor, which is very important for VXLAN EVPN, I need reachability. So I need to run OSPF. OSPF will only provide reachability. Using the reachability, you negotiate the EVPN VXLAN tunnel, which is yet to come, the configuration yet to come. Now, here on the tunnel interface, I said you are going to use BGP as a host reachability protocol. For this BGP to reach, it needs the underlay OSPF. and provide the router ID if you want to statically provide. Now here comes the BGP story. First of all, we form the neighbor to the remote loopback, and we say update source loopback 0. And then we need to go under EVPN, L2 VPN, EVPN. You remember when we configure layer 3 VPN, we used to say address family VPN v4. Here instead of VPN v4, we say L2 VPN, EVPN, and then activate the neighbor. And I was telling you there should be one router configured as a rendezvous point. This is the IP address of the first router. You configure as a rendezvous point. RP address means what? Rendezvous point address, gathering point address. This will be same for both the device because there will be only one rendezvous point. That's all. You see how simple it is, EVPN. You did not configure route target. You did not configure anything like VRF. And you don't need to even type this command, send the community both. It will come automatically if you activate the neighbor. All right, so that's the end of multicast replication. This is what going to come on the other router also. Same configuration. You see instance, VXLAN, encapsulation. You take the VLAN 101 traffic, put it into this VNI, and then these are the loopbacks that we got, and we got OSPF, we got PIM running, and then this is the host facing interface need to be a member of an access VLAN 101, and then the WAN facing interface running OSPF, PIM, and point to point is to avoid DR, BDR. And then you got the tunnel interface where you will say the tunnel source is loopback 0. Host reachability protocol. These are the three main commands in the tunnel. Host reachability protocol is BGP, and the replication need to be done using MPLS. That's all. After that, you go straight to BGP, enable the neighborship, and then go under L2 VPN, EVPN, activate the neighbor, and say the RP address. Boom! How easy it is. It is easy to see, but when you do 2 times, 3 times, only then you will understand. But unfortunately, we don't have the lab for this. It's the address of loopback of any one of the device. In my case, I want the left-hand side device to be the RP address. All right, I want the RP address to be the left-hand side device, and are they using 255.1? Okay, I'm using the same address as the RP address. Here it is wrong. Okay, this is not 1010. Funny people. So they configure something, but they put in the picture different thing. That's the wrong one. The address of the RP is 172. 16.
The other things also come to this.
For knowing the source and the destination.
So the master database of the MAC address everything will be in 255.
Yeah, correct.
So one more thing.
Hmm.
The first link,
Hmm.
I think there is a small correction.
Hmm. Hmm.
The IP address given is 254.
You see, there are two loopbacks. One is 255.1, another one is 255.2. Two loopbacks are there. You see,
First
255.2 and 254.2. Likewise, there 255.1, 254.1.
oh,
Yeah,
so this one I didn't understand.
it's okay. Nothing long. See, they want one to be an RP address. They want the other to be the VTAP address. If you want to use same for both, you can use it.
Oh,
One to be the RP rendezvous point, another to be the VTAP address.
oh.
Sorry, can you repeat again?
No, that's not important. Cool. Don't take it. He's asking why two loopback interface. I answered. One address in this example, they are using it as rendezvous point address. The other address they are using to form VXLAN tunnel neighbor, which is a VTAP address. If you use the same address for both, nothing wrong. Right? So I'll